Hello, we are going to be talking about how we can explain patterns in the number of zeros in a product. Remember, products are numbers that are being multiplied together. So if we look at letter A, Tamara's new horse weighs about 1,000 pounds. How can we show 1,000 as a power of 10 using an exponent? The exponent is the number that tells how many times a base number is used as a factor. So if we look down here, we have the exponent 3, our base is 10, and the exponent is being displayed here or represented 3 different times, and 10 is the factor, okay? And this is our product. Okay, so how can we get 1,000 by multiplying our factor of 10? So we know that 10 times 10 is 100, but we need to get to 1,000. So we know we need to multiply that one more time. And this is also represented as 10 to the power of 3. To be able to identify different patterns that we notice. So if we look, can we notice, and I'll agree, that the exponent 3 is being represented here and here. So what if I have 10 to the 4th power? I'm going to have 10 multiplied 4 times, and that also is going to be represented here. I'm going to add 4 zeros. I'm going to move over 3, place my comma. I have 10,000. So if we look at C, Tamara estimates that her horse will eat about 5,000 pounds of hay each year. How can we write 5,000 using exponents? So the number of zeros is in the factors is the same as the exponent. Okay, so if we have 5 times 1, we know that 10 to the power of 1, we're going to write 5 times 10. 10 is being represented once. If we have 10 to the 2nd, we have 10 being multiplied twice, and 10 to the 3rd power, we have 10 being multiplied 3 times. In our patterns here, we can notice that the number of zeros in our product is also being represented by our exponent. So in here we have 2 zeros, and our factor is being multiplied twice. In our product, we have 3 zeros, and that is also the same as our exponent. So 5,000 is also written as 5 times 10 to the 3rd. Okay, so when we use exponents, it's just a simpler and shorter way to show multiplication by powers of 10. We look at number 1 over here. Why are there 3 zeros in the product of 6 times 10 to the 3rd? So first it's asking us the product, we know, is the end result of a multiplication problem. So if I have 6 times 10 to the third, my exponent is representing my factor being multiplied 3 different times. So the equation will look like this. So we know from our previous page that our product is going to have the same amount of zeros as our exponent. So we know that our product must have 3 zeros, which gives us, move our thing over, and we have 6,000. What if we come over here in 3 and 4? We need to complete the pattern. Again, our exponent, our factor. So we have 10. Our factor of 10 multiplied twice. This also can look like this. And then let's do the bottom one. We have 10 to the fourth. This is what the equation would look like. So 10 times 1 is 10. 10 times 10 is 100. I skipped that third. And this one, we're just going to add our zeros. How many? 1, 2, 3, 4. 1, 2, 3, 4. Move over 3, and we have 10,000. So if we look at number 16, we need to write 10 times 10 times 10 times 10 times 10 with an exponent. Okay, so we need to write 10 with an exponent of how many times is our factor being multiplied? It's being multiplied 6 times. Therefore, our exponent is going to be represented with a 6. One box of printer paper has 3 times 10 to the second power sheets of paper. Another box has 10 to the third power sheets of paper. What is the total number of sheets in both boxes? Okay, so we know that one box of printer paper has 3 times 10 to the second. Our exponent is going to represent how many times that factor is being multiplied. So we know that 10 is going to be multiplied twice. And our little trick, we know that our exponent and our zeros are going to match. So we know that the first box has 300 sheets of paper. Another box has 10 to the third sheets of paper. Okay, we don't need the 3. Notice that there's 3 times 10, so we have our 3 here. We do not have that here. So this is being represented as 10 3 times. And our exponent is going to match our zeros, which means we need 3 zeros. It's just a little trick. Okay, we move our comma over. Are we done? No, because we need to know the total number of sheets in both boxes together. So you're going to add these two numbers together. Oh my goodness, dear Miss Emmerly. Okay, mistake here. Don't mean to confuse you. So we'll always go back and review our work, those simple mistakes. Okay, so 1,000, because this can also be represented as 1 times anything multiplied by 1 is itself. So this could be a good tool for you to use so you don't make the same mistake that I did. So now we have 1,000 plus 300 is 1,300 sheets of paper. Let's jump up to number 18. A post is put every 6 feet along a fence around a rectangular field that is 42 feet long and 36 feet wide. How many posts are needed? So we have a rectangular field. Okay, our posts are going to be put 6 feet along a fence. So along the fence, it would look something like this. Okay. We know that your field is 42 feet long and it is 36 feet wide. We know that if one side is 36, the other side is 36, and if that side is 42, we know that this is 42. What you need to do now is you need to establish the perimeter. What is the perimeter? We're not looking for the area. The perimeter is along the edge. So to do this, you're going to add your numbers together. And that is going to give you your perimeter. Once you have your perimeter, there's still one more step. So you're going to have your answer here. This answer is going to be divided by 6. And we are going to divide that by 6 because you're putting a post every 6 feet. Okay, so your answer will be 6 divided by blank. Whatever you get here will go here.